Hello everyone, I'm Bart Massey. Welcome once again to Introduction to Programming. Today I want to talk a little bit about the psychology of programming, although maybe psychology of problem solving or the psychology of making things would be just as good a title here because there's an awful lot of commonalities. I want to talk to you today about some of the attitudes and habits that will help you be a better programmer quite independent of your technical knowledge or skills. So, because it turns out that, that's probably the most important thing. So let's just dive right into that and talk first of all about your sort of mental attitude when you're a successful programmer. I have often heard people claim that they work better under pressure. I have never found any evidence that this is actually true. That doesn't seem to be how humans think, and the psychological literature will bear me up on this. Will defend me on this point, I think. You think the best and you operate the best and you do the best when you can move at a calm, relaxed, slow pace and keep that kind of a mental attitude. And it turns out that maybe more than anything else, your mood while you're trying to get work done is a key to success for any mental task, and programming is, if nothing else, a completely mental task. So you really need to, if there's stuff that's bothering you, if there's stuff you're dealing with that's distracting you or upsetting you, you need to clear it out as much as possible as before you start to try to program a computer or anything like that. You really need to ensure that you're well fed. It turns out that if you look at studies of people's performance, being hungry is incompatible with doing a good job on mental tasks. They take a lot of energy, and your brain really needs you to be fed. You need to be well rested, and that's really, really super important and really, really common for programmers not to do, including me. But what I'll find is that the quality and quantity of work I'm able to do is a direct function of how rested I am. It really does matter. You think these things are not a big deal. Programming's just all about knowing what to type and being smart and able to solve problems. Nah, it turns out that probably the biggest thing that matters is just your mental attitude, mood, setup for what you're doing. In the right state, you can solve great problems and make great things. In the wrong state, it's almost hopeless, and that's sort of independent of everything. When we're solving a problem, we tend to spend time in one of two states. There's what I'll call the reflective state. You're thinking about your approach to the problem. What am I doing here? How am I doing it? You're thinking about how much work things are going to be and how much is, what's going to have to get done to get things done. If you get stuck, you notice you're stuck. If you make a mistake, you notice you've made a mistake. This is the mode, it's called in the psychological literature sometimes type 1 thinking, type 2 thinking, which is sort of the mode where you're actually paying attention and you're actually using your full reasoning faculties. The other state that programmers spend a lot of time in is this state that is referred to often as flow state. And in the flow state, the real world fades away. What you're doing fades away. You become immersed in the problem. You're not paying attention to anything else. You don't notice time passing. You don't think about what you're doing on the problem. You're just fully engaged in the space of the problem. It's like what you do if you're watching television or a movie or maybe listening to music or reading or whatever. Those are all typically flow state activities where you don't consciously do them. They just happen. Both states are useful when you're programming a computer, but there are traps here. It's really, first of all, flow state is the fun state. We usually associate being in flow state with fun activities, and that's because it's really fun to be completely immersed in some different thing and make the real world slip away. And that's cool, and it's true for programming too. If I'm programming not thinking about other things, I'm having a good time usually. But flow state is dangerous to your success. It feels like you're making great progress. Everything feels like it's going great. Because you're not reflecting, because you're not paying attention to what's going on, it's super easy to just try the same thing over and over a little bit differently because you aren't stopping to think that maybe you're not getting anywhere with this. It's really easy to get into a bad physical or mental state. You find yourself getting hungrier and hungrier, sleepier and sleepier, needing more and more to use the restroom, but you don't because you're not paying attention. You find yourself getting crankier and angrier, but you don't because you're not paying attention. And so you get in this situation where you're not being very functional, but you don't notice you're not being very functional. And that's really, really easy to do. And it's really, really hard to stop doing, because to stop doing, you have to pay attention, you have to attend, you have to notice. It's really common for programmers late at night to spend an hour banging on a thing without even noticing that the hour's gone by. If you interrupted them and asked them how long it had been, it's been 5 minutes. No, it's been an hour. And it's really common for that to be not a very productive entry, not a very productive effort. So you really want to think hard about how to get yourself out of flow state when you don't need to. One classic approach, in recent years, somebody has promoted it real hard as something they're calling the Pomodoro method, and I've put a link on the slide to their webpage describing the technique. But I used to do things like this way before Francesco Cirillo popularized it. You literally set a timer. You say, how long do I want to spend in flow state? Cirillo suggests 25 minutes. I would actually suggest even shorter than that, 15 or 20 minutes. And you literally make a loud timer that will, he used an Italian tomato timer, which is why it's called Pomodoro, but whatever. It's any timer that makes a loud noise when it goes off should work. And when that timer goes off, when the loud noise happens, you immediately stop. You're immediately out of flow state for a second because the noise happened, and a noise will knock you out of flow state if it's loud. And you'll stop, and you'll completely stop what you're doing. You'll reflect, what have I been doing for the last 25 minutes or 20 minutes or 15 minutes, however long it's been? What's going on? And then you'll take a short break. You'll literally walk away from the keyboard, walk away from the screen for 5 minutes, not attend at all to trying to solve this problem. You're just like, no, my timer went off. I'm going to not be in flow state for 5 minutes. I'm not going to be banging on this problem for 5 minutes. I'm going to then plan the next interval as I sit back down. I'm going to say, well, what do I want to be doing with the next block of time? And off I go again. And that sounds like a lot. It sounds like a sort of overkill for solving problems, but it turns out that it really does help you, especially at the beginning when it's really easy for you to fall into flow state. It helps to jar you out and make sure that you spend some time in reflective state as well as in flow state. And what you'll find is when that timer goes off, you'll be like, wow, I'm really hungry, or wow, I'm really thirsty or sleepy, or I need to use the restroom right now. It will be amazing to you to find out that those interruptions, those enforced breaks, call attention to things that you've really been neglecting that you didn't even notice you were neglecting, because that's how flow state works. So I'm not saying don't get into flow state. A lot of programmers try really hard to arrange their stuff, as we talked about when we talked about ergonomics, try to arrange their stuff so they can get into flow state because it feels good and because it can be effective for some kinds of work. But I'm saying don't get stuck in there. It's a bad place to get stuck. Speaking of getting stuck, it's super common that you get stuck in programming. You don't know what to do next. You have got to a place where you can't make anything work and you don't understand why. You have no ideas about what else to try. You've tried some things and it seemed like they should have solved the problem, but they didn't. Welcome to programming. Welcome to any kind of problem solving, really, but especially welcome to programming, where getting stuck is a really, really common occurrence. If you're in flow state, first problem is you won't notice that you're stuck. You will keep trying, like I say, the same thing over and over, or slight variations on the same thing, even though there's no real reason to expect them to work. So you really want to play Pomodoro or some other game and get yourself out of flow state so that you can notice you're stuck. And that can be the hardest part. Once you notice you're stuck, though, it doesn't do you any good unless you have some plan for getting unstuck. And really, the first answer when you're stuck is walk away. there's this sort of very American value of determination that we teach. You just got to bang your head against the wall until the wall breaks. It doesn't turn out to be a very effective technique in programming computers. It turns out that really hardcore, I will keep trying until I make it work without a break, without any kind of rest, attitude is not going to get you very far in this discipline. You really need to be willing to take time, let things percolate. One of the things that programming does is it uses vast amounts of time, and that's really wall clock time. You can spend that time staring frustrated at your computer, or you can spend part of it staring at your computer and part of it doing something else, but thinking about the problem at the same time. You know, the second thing's way more pleasant and probably just about as effective if you look at, you know, what I've seen and other people have seen with this. So seriously, when you're stuck, just stop. Quit trying to solve the problem for a minute, or maybe for many minutes. You can switch to a different problem, because usually, being programmers, we have 2 or 3 things going. Maybe the different problem's another programming problem, but probably not. Probably it's something different. You can look for help. So the internet is full of potential help. I should have a whole nother talk about how to use the internet to get help, but that's a place to look. You can look at the textbook we have in our course. You can look at, look around at things we've talked about before. Look around. Is there some way that you can get it? There's no cheating in this business, right? As long as you credit your sources, however you figure out how to get unstuck, that's a good way. Ask people. It's an art to understand when to ask people for help. And some people over ask and ask way too much and too early, which is a little frustrating for the people being asked, but it's what they pay me the big bucks for. Most people are really bad about saying, I'm stuck, I need some help, I need help understanding what's going on here, can you help me out? Ask anyone, ask non-programmers, ask your friends in a class, if you're in our class, if you know anybody who knows how to program, ask them, ask the TA, ask me. People want to help you learn, and that's a great way to get unstuck. A lot of times you're stuck because you've bitten off a bigger piece than you can chew, as the weird English metaphor goes. You've really taken a problem that's too big. A good way to get unstuck is to say, well, is there a small, tiny piece of this problem that I can try to solve? Because small things are easier to solve than large things. And then if you solve that, is there another tiny piece of the problem? Instead of trying to solve everything at one go, ask yourself if there's something you can do, something you can try to figure out how to solve at least a little of it, at least get a start on it. And then you form what we call in the fancy world of science hypotheses, right? You sit there and imagine what could be going wrong here. And maybe you write those imaginations down, but you certainly carry them around in your head and go, I wonder what could be going on here that I haven't thought of. And when I think of something, how can I tell whether that's the thing? There's a whole lecture on debugging that I need to give, but absolutely a big part of getting stuck is just having ideas about what to try next. And that's some ways to get unstuck. Like I say, you'll get stuck sometimes. You just need to get used to getting out of it, and it will happen. I mean, really, at the end of the day, it's like this. Most of the time, smart is just mentally ready to solve a problem. I've met some of the smartest people on the planet in my time on it, and they make mistakes. I've seen them all make mistakes. Nobody doesn't make mistakes. Eventually, though, they fix them because they're smart and persistent and have good mental habits. They're going to probably fix their mistake. Smart people get stuck, and then they get unstuck. Neither of these things are distressing. I make mistakes all the time. You've seen me make them in class already. I get stuck all the time. You've seen me get stuck in class already. That's part of the game. So you fix your mistakes, you get unstuck, you go on with your life. Smart people get frustrated. Absolutely, problem solving can be frustrating. And every so often you lose that mental attitude I've been talking about. And you find yourself in a situation where you're angry and frustrated and stuck and sad. Then you get it back together. Stop thinking this is dumb. It's just a programming problem. That's part of what breaks are for. It's part of what talking to people is for, is to sort of regenerate your mental attitude so that you can go back and solve the problem in the right state. What I'm trying to say is if you think you're a pretty good programmer and super talented, maybe you are. I don't know. But, you know, probably a lot of that, if it's true, has to do not with some kind of IQ thing, but with your mental attitude. Maybe you think you're terrible and won't be a good programmer because you're too dumb. That's baloney, probably. Certainly the first thing to work on if you're concerned is your mental attitude. You're just an average smart person. Treat yourself as an average smart person and think of yourself as an average smart person, because that's what we're all doing together, is being smart on average. So that at least scratches the surface of what I think about when I think about the psychology of programming. I hope that was helpful. And I hope you're all staying safe and well in these difficult times. I look forward to talking to you again soon. Take care.